Okay, let's get right into it. We're going to talk about a fundamental conflict, a battle that's happening inside all of our heads, right now. This isn't just some abstract idea. It's a design conflict between our ancient biological brain and the ruthlessly efficient technology we carry around in our pockets every single day. Just let that sink in for a second. The single most complex thing we know of, a marvel of millions of years of evolution, is being outmaneuvered, outsmarted, and by something that's, 30 years old? Seriously, how is that even possible?
Well, it's because this is a battle of architectures. Right here on the screen, you've got the two fighters. On one side, you have the beautiful, sprawling, organic mess of a biological neuron. And on the other, the clean, cold, perfect logic of an artificial one. One evolved for adaptation and survival, the other was designed for pure logical speed. And that single difference, that's everything.
Yeah, that really is the big question, isn't it? How can our brains, these incredibly powerful things, be so vulnerable? To figure that out, we've got to look under the hood of both of these systems.
Okay, so first up, let's talk about our protagonist, the human brain. But here's the thing you have to understand. It wasn't built for right now. It was built for the savannah, like 300,000 years ago. It's basically running on ancient software designed for one thing and one thing only, survival. And its core programming, seeking out what's new, making sure we belong to the group, and spotting threats, that's what this is all about.
And the scale of this thing is it's mind-boggling. Your brain contains about 100 billion neurons. To put that in perspective, that's more neurons in your head than there are stars in the Milky Way galaxy. It's absolutely wild.
And this is the basic building block of that whole system. You've got the dendrites, which are like little antennas grabbing all the incoming signals. Then the cell body, the soma, processes it all. And if the signal is strong enough, bam, it fires an electrochemical pulse right down the axon to talk to other neurons. It's this incredibly elegant living circuit.
And wait, this is where the numbers just get completely insane. Each one of those 100 billion neurons can connect with up to 10,000 other neurons. You do the math on that, you're looking at over 100 trillion connections, or synapses. Your brain isn't just a computer, it's a whole universe of thought.
All right, so now for the challenger. If our brain is this sprawling, evolving rainforest, the computer is, well, it's a perfectly gridded, brutally efficient superhighway. It's built on a totally different foundation, not for messy survival, but for pure, unadulterated logic and speed.
And this, right here, is its primary weapon, an artificial neuron. It takes in a bunch of inputs, assigns a mathematical weight to each one to decide how important it is, and if the total hits a certain number, it fires a single, clean, binary output. Yes or no, 1 or 0. It's a massive oversimplification of our own biology, but it is brutally effective and unbelievably fast.
Okay, so it kind of seems straightforward then, right? Our brains are for creativity and art, computers are for spreadsheets and math. They should just be good at different things. What's the problem?
Oh, that's where it gets complicated, because it's not just that they're good at different things. The computer's specific strengths are almost surgically designed to exploit the brain's ancient weaknesses. This isn't a fair fight. It's asymmetric warfare, and the technology was deliberately engineered to target that 300,000-year-old operating system we all have.
And this chart says it all. This is the mismatch. Your brain cells fire a few hundred times a second? A modern computer chip fires billions of times a second. It's not just a mismatch, it's an ambush. It is literally like trying to take a sip of water from a fire hose that is spraying data directly into your brain.
Oh my God, that's it. That is the feeling, that constant, low-grade hum of anxiety you feel when you've been scrolling too long. It's not just being tired, it's a specific state of being. It's cognitive overload. It's your brain waving a white flag. Exactly, that's what it breaks down to. We stop looking inward to understand how we feel, because an app can give us a quick label. That erodes introspection. We outsource our ability to cope to algorithms, which weakens our own resilience. And we get obsessed with likes and metrics, turning our own lives into a source of constant, hyper-monitored anxiety.
So what does this do to us long term? I mean, is this just like being exhausted after a long day at work, or is something more permanent going on here?
This is where it gets really serious, because your brain isn't a static thing. It physically rewires itself based on what you do. So every time you refresh your feed, every click, every scroll, you are literally carving a path in your brain. You're not just getting distracted, you're building a neurological superhighway for distraction.
Wait, so you're saying this isn't temporary? We're physically changing our brains? That is genuinely terrifying. So we're not just losing focus in the moment, we're actually training our brains to be incapable of deep, focused thought?
We are. But it's not hopeless. The very same principles of intentional design that got us into this mess can get us out. What if, instead of building tech that fights our biology, we built technology that works with it? What if we aimed for symbiosis, not conflict?
Wow. Okay, look at this timeline. For so long, this was pure science fiction. I mean, moving a robot with your mind in 1988, that was revolutionary. But look at that last jump. We're now decoding complex speech directly from brain signals, almost at the speed of a normal conversation. The barrier between mind and machine is starting to dissolve. And this right here is a perfect example of that potential for symbiosis. We're using the incredible pattern recognition power of artificial neural networks to better understand the beautiful complexity of our biological ones. In this case, technology is a microscope, not a weapon. It's designed to augment our health and understanding, to respect our biology, not exploit it.
And that's really what it all comes down to. This story isn't about technology being good or bad. It's about design. It's about choices. This conflict was created by deliberate choices, and it can be resolved by making better ones. So the question we all have to ask ourselves is, now that we know how our brains actually work, can we finally build a world that respects our own biology?